Hi, AP Precalc. This is Mrs. Leong, and I'll be teaching lesson 14.2, part A, some limit laws. All right, so we have a few laws or properties here that we can use. For example, if we have the limit of a constant, like let's say A is just some number, some constant, we know that as x goes to c, this will actually just remain that same constant A. All right, that one's pretty easy. For this one, the limit of x, if x approaches c, this limit then must approach c also. All right. Moving on, limit to a sum. If we have the sum of two functions in a limit, we can actually split those apart. And this would be the limit as x approaches c of f of x plus the limit of g of x, oops, too many parentheses, as x approaches c. So you can split up those limits. And same for differences. If this was a minus, that would be a minus. Okay. Product also, you can split those up. This would be the limit of f of x as x approaches c times the limit of g of x as x approaches c. So you can find the product of the functions and then take the limit, or you can take the limit of the functions separately and then multiply those together, and you get the same thing. All right. This one is limit of a power. All right, so if you have a function being taken to an exponent and then you take the limit, you could also, you could also take the limit of the function first as it approaches c and take that answer to the power of n. All right, and this is only if n is a positive integer. All right, so there's a criteria for that one. All right, and then limit of a quotient. If you have a quotient of two functions and then you're taking the limit of that, you can take the limit of each function separately and then divide. So limit of g of x, too many parentheses, of x going to c. All right, and this is assuming that the limit of g of x as x approaches c does not equal to 0, of course. All right, so what does that mean? Well, when we get to problems like this, we can simplify it fairly easily. All right, so we're trying to find the limit of this function as x approaches 2. We know that this is going to be the same as the limit of f of x as x approaches 2 plus the limit of 3 of x as x approaches 2 minus the limit of 4 as x approaches 2. All right, and so this is just going to be 2 squared plus 3 times 2, and this will stay at 4. All right, so that just gets you answer of 6. All right, so in general, all that kind of boils down to that if you have the limit of a polynomial p as x approaches some number c, you can just plug in that constant into the polynomial. All right, so you do not have to show all this because we know that using all those properties, we can just plug into the x. And that gets us our answer. All right, flip to the next page. When can't you just plug in? All right, so when the denominator goes to 0. So now a couple things can happen. You can have numerator and denominator goes to 0, meaning you have the same factor. And graphically, you're going to have a hole in that graph. Or you have something in the numerator other than 0, and then just the denominator goes to 0, and then you have a vertical asymptote, all right, where that denominator goes to 0, okay? So if you wanted to know kind of if it was going to positive or negative infinity, you can make a table on your graphing calculators, and you can see if it infinitely increases or infinitely decreases, going to positive or negative infinity. All right. So for example, all right, if I have the limit of this function as x approaches 2, I can factor this. Well, first off, if I were to plug in 2, right, you get 4 minus 4 over 2 minus 2. So we get that 0 over 0 situation. So we know there's going to be a hole. All right, so when we factor the numerator, we see, in fact, there's that common factor here. So definitely have a hole at x is 2. Okay, and so we can reduce that down. And so now we have the limit of x plus 2 as x approaches 2. Plug it in, and we get 4. All right, so graphically speaking, what does that look like? Well, this is the graph, okay, where you have this line, but you have a hole at x is 2. But since we're talking limits, we're just getting closer and closer to that value. Okay. And so we're getting closer and closer to that value of 4. All right. So even though this function doesn't exist at 2, the limit approaches 4 as x approaches 2. All right. So let's go ahead and take another example. Same idea. We have the limit of a function as x approaches 2. Okay. If I plug in 2, I get 0 over 0, so I'm going to factor. Okay. And once I factor this perfect cube, I get this. And then these two reduce, leaving me with this. All right. And now when I plug in 2 into those x's, I get 12 over 4, which gets me an answer of 3. All right. Let me show you just a few more, and then I'll have you guys try some on your own. Okay, so find each limit. So for number 1, all right, pretty simple. There's nothing to factor. I can just plug it in. So I get 2 minus 5 times 3, which gets me negative 13. All right. Even with questions like number 3, we can plug in. We get 1 minus 2 times 0, getting me 1. All right. Why don't you guys, let me do one more actually. Let me do this one. All right, so this one I do need a factor because when I plug in the negative 1, I do get 0 over 0, so I need a factor. So take out your GCF for the numerator, and then take out your, or do a difference of perfect square on that one. Okay. All right, and that reduces down to x over x minus 1, which now I can plug in, and I can see that it will approach negative 1 over negative 2, which simplifies to positive 1/2. All right. Why don't you guys try the rest of this page? So go ahead and pause the video, and once you're done with this entire page, all the way to number 8, unpause, and then you can check your answers. All right, so here's the answer to the rest of this page. For number 2, just plugged in, got the answer of 2. Number 4, plugged it all in, got the answer of 5 over 3. All right, number 6, had to do some factoring, and then plugged in and got the answer of 3. Number 7, did a lot of factoring by grouping, able to factor out an x plus 1, which reduced, plugged in the negative 1, got an answer of 4. All right, and then the challenge was number 8. All right, so for number 8, I used my double angle formula for sine of 2x to get 2 times sine times cosine of x. All right, and then from there, using the property, I can separate those products. So I took out the 2, separated that out, separated out the sine of x over x, since they gave that to us, and then the cosine of x. All right, so I separated out those 3 things. Limit of 2 as x goes to 0 is just 2. This one they told me was just 1. and cosine of 0 is also just 1. All right, so multiply that together, got the answer of 2. All right, that's it for this part of the lesson. Go ahead and continue with your homework, and I'll see you next time.